Welcome to week 1 in quarter 2. In this we will reflect points across the line. Triangle ABF is located in the third quadrant of the coordinate plane. If triangle ABF is reflected across the x-axis to obtain triangle A prime, B prime, F prime, which quadrant will triangle A prime, B prime, F prime lie in, and will it be congruent to triangle ABF? We're going to start by finding the points of our pre-image triangle ABF, and we're going to set up a table and then locate the points. I'm going to use a straight edge to set up my table. I'm going to go ahead and draw a straight line across the top using my straight edge, and then I'm going to take my straight edge and I'm going to rotate it 90 degrees, and I'm going to use it to make some columns. So I'll make this first column, and I'll make this second column. Alright, and in that first column, that will go my triangle ABC coordinates, or ABF. And in the third column, I'll put the coordinates for my image after the reflection. So that'll be triangle A prime, so again we have triangle ABF, and we'll end up with triangle A prime, B prime, F prime. So I need the coordinates for point A, for point B, and for point F. And then I need the coordinates for point A prime, point B prime, and point F prime. For point A, I can read it off the graph. So I see I'll go left 4 and down 5. So that's -4, comma -5. For point B, I go left 2 and down 3. So -2, -3. And for point F, I go left 5, down 2. So -5, -2. These are my pre-image coordinates. In the middle column, I'm going to see if I can come up with a transformation rule. So I'm starting with my XY coordinates, and I want to see if I can figure out a rule for the new coordinates, the transformed coordinates that I end up with. All right, so I'm going to start out by using my compass to help me find the first point, the first reflected point across the x-axis. So I'll reflect B across the x-axis first. So what I'll do is I'll take my compass, I'll take the pointed end and place it on point B. And notice that my drawing is skewed to the left. It's kind of slightly rotated to the left, so it may be off a little bit. It's fine. We'll make it work. Then I go ahead and after I put my sharp end at B, I go ahead and I swing around, and so that my compass will intersect my line of reflection in 2 places. So my line of reflection is the x-axis, so I got to swing it around so it intersects it in 2 places. In 2 places, 1 and 2. Let me do that in a different color, 1 and 2. Now, keeping my compass at the same setting, I'm going to go ahead and move it so that the sharp end is at one of the intersection points, one of the points where it intersects the x-axis. And I'm going to swing it around again to make an arc. And then I'll place the sharp end at the other intersection point. Again, without adjusting my compass, just locating it at that intersection point. And then I'm going to swing it around, and I'm trying to find where those 2 lines intersect, and for me they intersect around this point here. Okay, I can see that coordinate where they intersected. That's going to give me coordinates for point B prime. So this is where B prime is located. And the coordinates for B prime are left 2 and up 3. So left 2 and up 3. I also noticed that if I bring my straight edge, I noticed that the line connecting point B and point B prime makes a 90-degree angle with my x-axis. And so I see, and I also see that, and that will always be the case. Your line of, when you connect the 2 points, the pre-image and the reflected in the image after the reflection, the segment between the two will always be perpendicular to your line of reflection. And I can see that from this side, from B to the line of reflection, I go up 3. And then from the line of reflection to get to B prime, I also go up a distance of 3. So they're going to be, that's the other thing, you're going to be the same distance from the line of reflection. Think of it as a mirror. So I can use that, what I just discovered there, to figure out what A and what F should be. So let's start with F. F, we're going to take the line that's perpendicular, so we're just going to use a straight line right here. And we can see that F is a distance of 2 from the line of reflection. And so the perpendicular distance for F prime will go up 2, the same distance, 1, 2. So F prime will be here. Coordinates for F prime, left 5, up 2. Left 5, up 2. And then for point A, same thing. I got the perpendicular line going perpendicular to my line of reflection, which in this case is my x-axis. I see I go up 1, 2, 3, 4, 5. And so then I'm going to go 5 on the other side of the line of reflection. So 1, 2, 3, 4, 5, right here in this point. So this point here is A prime. And the coordinates for A prime are left 4 and up 5. Left 4 and up 5. I could also do my compass method for each point. Either way will work. Now I'm going to connect the points on my transformed figure. So I'm going to connect A prime to B prime and F prime to make a new triangle, my image. So now after connecting both points, I can visually see my pre-image, which is in black, and my image, which is in blue, after the reflection across the x-axis. So essentially this is the mirror image of my original. Now I'm trying to see if I can see a rule. Let's look at our coordinates. We have -4, -5. We look to the right, we have A prime is -4, 5. And we look down. We notice that on both sides, the original and the reflected coordinates, the x value is the same. The x is not changed. So the pattern we notice is that our x values are the same. So my x coordinate is not changing. My y value, I see I go from -5 to +5, from -3 to +3, from -2 to +2. So I can see that my y value is changing signs, so it's actually being multiplied by a -1. So this will be my rule for reflection across the x-axis. Now let's answer the remainder of the question. So the question says that triangle ABF is located in the 3rd quadrant. So let me go ahead and identify all my quadrants. So these are my 4 quadrants. This is quadrant 1. This is quadrant 2. This is quadrant 3. And this is quadrant 4. In quadrant 4. So 1, 2, 3, and 4. So again, I can see that the original, the black triangle, is in the 3rd quadrant, and my blue triangle ends up in the 2nd quadrant when I reflect it across the x-axis. So triangle A prime B prime F prime now lies, so a triangle A prime, B prime, F prime is in the second quadrant. I can also see that my new triangle, the points are in relatively the same positions relative to one another. And this was a rigid transformation. Reflections don't change the size. It just, the figure is just in a different location. So this is a rigid transformation. And in rigid transformations, the triangle will remain congruent because all of the sides will still have the same measurements and they will have the same angles. So this triangle, triangle A prime, B prime, F prime, is going to be congruent with the original, the pre-image triangle A, B, F.